Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to take a look at the algebra behind the binomial distribution. So that's what we're going to do, and I think it's worth seeing, and I'll show you why here. So this is the algebra of the binomial distribution. Now, let's take a look at something. For example, I'm going to go up above and I'm going to grab the work we just did. I'm going to grab well, actually, we'll write it here. Remember, we talked about a multiple choice test. So I'm going to just write MC. So that we had a multiple choice test. It had 5 questions. Each with 4 possible answers. One of which is correct. And then we found 2 ways. So then what we did is we said, well, let's just see what would happen. What's the probability of just guessing 3 out of 5 correctly? So we did this 2 ways. The first way we did it is we said that you could find it by writing the word. And so when we wrote the word, I'll write it this way. We wrote it as 1/4. We got it 3 correct. So we had 1/4 times 1/4 times 1/4 times 3/4 for an incorrect one times another 3/4 for an incorrect one. But we said that CCCII was a word. So we wrote that as 5 factorial over 3 factorial 2 factorial. But we found out that this is really the same as 5 choose 3 correct times 1/4 cubed 3/4 squared. There. And we also said, well, that is a function in the calculator. What function is it? We said that's the function of binom PDF, the number of trials 5, the probability of success 1/4, and the number of desired successes 3. Now, I've shown you 2 routes to solve a binomial distribution. I think the first one is definitely the wiser one. Now, when would you not use this first method? Would you write out the word and figure out how many words are represented? When your samples get large, or the number of trials gets large, say if it's even 20 or 50 or 100, at that point, if you're dealing with problems that big and you know that it's a binomial experiment, that's definitely, to calculate that, you would definitely use a calculator. But to maybe set the problem up so that you're sure that it is a binomial experiment, that would be something that you might want to use the word operation for, and then use the calculator to put the final numbers down for you. So I think understanding the first is the key to being able to use the calculator correctly. But there's one more piece to this puzzle, and that is that the pattern of a binomial distribution is a simple function in a calculator, and I want to show you where that comes from. So let's begin. So we're going to do some algebra, and if it's been a while, well, this will get you warmed up, and if you like algebra, then I think that you'll be able to help guide me through this. So here we go. We said initially that the probability of success plus the probability of failure is 1. So I'm going to write it that way. P plus Q equals 1. Now, there's one rule in algebra that matters. One rule. That is, if you perform a mathematical operation on one side of the equal, that's fine. Do whatever you want. Just do the exact same thing on the other side. Well, let's do this. let's take it and let's square both sides. Okay, that's legal. Well, what is 1 squared? Well, that's still 1. But wait a minute, what happens on this right-hand side? Well, p plus q squared, I'm going to tell you what it's not. It is not p squared plus q squared. It's a common mistake. It's not. What you have to do is you have to remember what squaring means. It means p plus q times p plus q. Like that. Well, then what do? We distribute. So we would distribute p times p. That would give me, right here, a p squared. And then we take a p times the q for a plus p q. And then we would repeat that again, now starting from this q in the first parentheses. So q times p. I'm going to write it again. The order of q and p doesn't matter. So pq. And then we have a q times a q for plus q squared. All this is distribution. This is the distributive property. And this becomes p squared plus 2pq plus q squared. Now, you know what? That was kind of fun. I think we should try it again. So let's do that. I'm going to then let's cube it. So 1 cubed. And if we cube the other side, that's perfectly legit. But what we want to find out is how that expands. Well, let's see. So p plus q cubed is p plus q times p plus q times p plus q. Well, look at this. Look at this. We already know, what do we know? We know this. We know what p plus q times p plus q is. We've already done that. That's this. So I'm going to use that. So let's do that. Let's write this then as p plus q times p squared plus 2pq plus q squared. Okay, and now let's distribute again. So I'm going to take this, we'll do it in different colors. How about we'll do an orange distribution? So orange is going to give me a p cubed, and then a p times 2pq, that's going to be plus 2p squared q, and then a p times a q squared, so plus p q squared. And then how about this red? Let's do a red distribution with q. So q times p squared is going to be a p squared q. And then q times 2pq is going to be plus 2pq squared. And then our last one is q cubed plus q cubed. And now I'm going to just, look, I did this in this order of lining up my terms on purpose. I know I do a lot of things on purpose. It's amazing how much direction math can provide. Watch this if we just add these up. P cubed plus, I have 2p squared q plus one more p squared q. That's 3p squared q plus another 3p squared q plus q cubed. Okay, at this point, I think it would be fun if we tried this. If we tried 1 raised to the 4th power times p plus q raised to the 4th. And I would encourage you to pause the video and try. I really would. But instead, I want to show you a pattern. The reason for this pattern is the same reason that your calculator can so easily compute these for us. Let me show you this pattern. I'm going to start the pattern with 1 equal. Oh wait, before I do this, notice this. Even when the left-hand side, it doesn't matter what power you raise 1 to, the answer is always 1. So what this is telling us is that after we distribute all the p's and the q's and we get all these numbers, that it's still a probability distribution. It's still going to sum to 1. So that's what's so powerful about this, is that the 1 on the left-hand side stays 1. So we know that even as we raise it to the whatever power, it still just adds to 1. That's the big key. But let's look at the pattern now. So here we go. The pattern was this. We had a p plus q. And then we did it again. Well, what did we say? This time we had a p squared. Let's go take a look. Oh yeah, it's right up here. So I have a p squared plus 2pq plus q squared. And then let's look at our next one. Our next one says p cubed plus 3p squared q plus 3p q squared plus q cubed. Okay. All of these, they always add to 1. Now, we can write the next one. We can go through the algebra up here if we wanted to. But this is what I propose. Notice that if you just write a p, it's the same as writing 1p or 1p squared or 1p cubed. Notice they all start with a 1. This next one also is going to start with a 1. Okay, so this first line, this was raised to the first power. The second line was raised to the second power. The third line was raised to the third power. This fourth line is being raised to the fourth power. Notice that the first p term, is whatever power the whole piece was raised to. So this is going to be p to the fourth plus. Now let's look up above. To get this next number, so look at this number. Notice that if I take 1 and I add 2, I get 3. 1 and 2, I get 3. And then if I take this 2 and I add it to this 1, I get 3. Well, if I repeat that pattern, if I take the 1 in the third line with a 3, that's going to be a 4. And if I come over and I take this next 3 and this 3, I'm going to get a 6. And if I take this 3 and this 1, that's going to be a 4. And then we know that the same way the p's went down this outside edge, the q's are going to do the same. So we're going to end with a plus 1q to the fourth. Now, how do we fill out the rest, the p's and the q's? Well, it's actually pretty clever how this works. Let's do this in pink. Because notice that, look at the exponents. In this first one here, it was raised to the third power. In the second one, it's p squared and then q to the first. Well, 2 plus 1 is still 3. And then now, look, now we have p to the first, q squared. Well, that's 1 plus 2, that's still 3. And finally, we have q cubed. That's also 3. So the total sum of the exponents is always the total power that it was raised to. So if we continue this, notice this. The p starts out at 3, then it goes down to a 2, then it goes down to this 1, and then it goes down to a p to the 0. And then the q's, they start the other side. 3, 2, 1, and then q to the 0, which is just 1. So now we can write the rest of this. Our next one is going to be p. So it was a 4, now it's going to be a 3. But we need the exponents to sum to 4, so it's going to be q. You can write q or q to the first, plus. So we had p to the fourth, p cubed. Now we have p squared. And then we're going to have a q. Well, q went from this is the first one, is q to the 0, q to the first, q to the second, plus. And now we have p's go down, so this is p to the first. That means we have q cubed. Okay. Let's make sure you've got this pattern. I would encourage you to pause the video and see if you can write the next line. In other words, see if you can write this when we take it to the 5th power. So see if you can write that. Pause the video, and when we get back, we're going to write this down together. So pause it. All right, here we go. I hope you tried this. So remember, this always adds to 1. So we have our first one is going to be 1 p raised to the 5th power. And then plus, now we take the 1 plus the 4, so we're going to get a 5. The p goes from 5 down to 4. The q goes from 0 up to 1. Plus. Now we take the 4 and the 6 to get 10. And then the p goes from 4 down to 3. The q goes up to 2. Plus. 6 plus 4, that's 10. P goes down to 2, q goes up to 3. Then we take the 4 plus the 1, that's 5. Then p goes down to 1, q goes up to 4, plus we always end with a 1, and now we're at the q raised to the 4th, and that should be your 5th line. So you might say, why is that so important? I want to show you. Let's come back up here. Can never lose sight of all these pieces. So let's go back to where we started. Let's take a look at this piece. 5 factorial divided by 3 factorial, 2 factorial. Well, let's take this piece right here. Actually, I'm going to bring it down below so we can work on it by where I'm going to need it. Let's bring it down here. Okay, and here we go. I want to take it a little bit further, so let's do this. The 5 choose 3 is 5 factorial over 2 factorial, 3 factorial. Oops, I should just do that below. That's not correct right now. 5 choose 3 is, and I'm going to erase this. Don't do that. Do this instead. This is 5 factorial over, remember what it means. It means 5 minus 3 factorial, 2 factorial. Well, 5 factorial is 5 times 4 times 3 times 2 times 1. 5 minus, oh, whoops, not 2. This should be a 3 factorial there. Okay. Then, so now I have 5 minus 3, that's 2 factorial, that's 2 times 1, times 3 factorial, that's 3 times 2 times 1. Well, look at this. Look at what happens here. The 3 2 1s cancel, and then the 2 reduces the 4 down to a 2, and so what am I left with? When I clean all that up, I'm left with a 5 times 2, but that's 10. Well, wait a minute. Let's put this back in now. So this is 10 times, and remember what the 1/4 represented. The 1/4 represented the probability of success. Well, that's p, raised to the 3rd power. 3/4 in our example was the probability of a failure, squared. Now, let's take a look. This term right here is this term right there. That is no coincidence at all. And what does this mean? So let me show you what this means. This means that if you add the exponents, so I'm going to use lots of little highlighters. If we added the exponents, that's the number of trials. There was 5 trials. And there was 3 successes. That's what the 3 means. There was 2 failures. And it happened 10 different ways. That 10 counts all the mathematical words. So let's take a look at another one. We should have a different color for another example. So let's take a look at this term right here. What does this tell us? This says that, again, there was 2 plus 3. There was 5 trials. There was 2 successes, 2 success, 3 failures, and it happened 10 different ways. There's 10 different ways that you could get 2 correct and 3 incorrect. And let's take a look at just one more, see if we've got this pattern. We'll look at it in pink. Let's take a look at at this second term, 5p to the fourth q to the first. Remember, 4 plus 1 again is 5 trials. The probability, that means that in this case, there's 4 successes. That's what the 4 stands for. The 1 on the q stands for the number of failures. And the number of ways that you can have 4 successes and 1 failure is the 5 in front. And so if you very simply create this picture, you can now figure out the answer to any relatively small binomial distribution. And one last thing, I need to give full credit. This is not my discovery. This is what's called Pascal's triangle. Pascal's triangle. And that is how you connect the pictures to the calculator all the way back to its underpinnings of its algebra. I hope that helps. Thanks for watching.